PowerPoint up.
Okay.
There you go.
I'm broadcasting right now, so I see folks are coming in. Thank you so much, everybody, for being here. For those of you who haven't been here before, we are doing a cannabis webinar series from the Grand Rapids 2030 district. And so we've been having a few every Tuesday at this time for the last couple of weeks, and there's more to come. So make sure you keep this in your calendar and stay tuned. And today we're doing a deep dive into dehumidification, and I'm so excited to hear more about this. We're looking at the importance of indoor agriculture, HVAC, its fundamentals, and thinking outside the box. So for starters, my name is Jillian Gim. I always forget to introduce myself. I'm the program manager for the Grand Rapids 2030 district of the U.S. Green Building Council of West Michigan. And we have today Michael Ward, CEO and founder of Harbor Farmz. Michael.
Thank you, Jillian, for having me today.
Thank you for being here, Michael. And we have Mitchell Kelley from Trane Commercial HVAC of North America. He's the brains behind a lot of this information today. Mike.
Well, thank you, Jillian, for the for the introduction there, and I'm happy to be here. Nice to meet everyone virtually. Welcome into my home office.
Yeah, we're all tuning in from our home office, huh? And last but not least, Rachel Fredrickson, a very valuable partner through Consumers Energy and indoor agricultural specialist. So thank you, Rachel, for being here as well.
Hi, everyone. Thank you, Jillian, for having me, as always.
As always. So a few housekeeping before we begin. So remember to use the Q&A. So as this presentation is going through, Mitchell and Michael and Rachel are going to be having a lot of conversation. If there's a question that pops into your mind, just shoot it in the Q&A just as it comes. And we'll make sure to be able to address them either at the Q&A at the end of the presentation or maybe like fiddled out through in between. So make sure you use the Q&A and be mindful of the chat. Chat is a way for everybody to be able to talk with each other. And we encourage active dialogue through this virtual world that we're in right now. And lastly, at the end of the question slide, you'll be able to see contact information for you to follow up with questions if there is. You always can get a hold of us at the 2030 district. We care very much about what you think. So there'll be a survey coming out at the end of this. It'll be what was the biggest thing you learned, what more do you want to see of, and how can we improve? And that survey is very important to us. We really care about what you say. So when you see that survey followed up with the recordings of this presentation and the slides, go ahead and fill that out and let us know how we can be better supports for you. And last but not least, our guide just came out. So for everybody who has been on a helper with this guide, thank you so much. You can see this on the Grand Rapids 2030 district website. It's a public PDF meant for you to be able to achieve the licensing and ordinance goals for the city of Grand Rapids if you're developing within the city limits. And more best practices yet to come. So thank you so much, everybody. I'm very, very excited to hear what Mitchell has to say today. There was something the other day that caught my eye when we were planning this webinar. Michael had said that, yes, this is dehumidification, but it's just so much more than that. And with that note, I want to have y'all turn it over to Mitchell, and hear what he has to say. So thank you, Mitchell, Rachel, and Michael for being here. Hey, Mitch, can you share your slides? Awesome.
All right. I'm hopefully off mute and presenting properly. Jillian, can you confirm that for me?
Yes, I see you and I see your slides.
Okay, excellent, excellent. Well, thank you everyone for coming today. Like Jillian said, my name is Mitchell Kelley. I work for Trane Commercial North America. I am both a mechanical engineer as well as a salesperson for the company, and have a bit of experience in this new market of indoor agriculture, really something that's grown quite a bit and developed quite a bit, especially over the last few years, into something that was previously very rudimentary and now is something that is very complex and detailed in its both design and implementation. So with that, we'll dive right in. So a quick agenda for today, things we're going to be going over. First of all, just what is indoor agriculture? Now, naturally, this webinar series has been about the cannabis industry, but a lot of the principles at play apply more broadly in the indoor agriculture market. And the same techniques that we've seen in the cannabis grow space are now being applied throughout the, I guess, broader agriculture market space. So we'll talk a little bit about both that market landscape as well as the market landscape specifically with cannabis. Then we're going to dive inside the grow room itself, talk about a little bit of high school biology, get into the shoots and roots conversations. And then we're going to go into the load calculations, what you need to keep in mind, how you really develop lighting and irrigation load, type of, I guess, both decision making around that, what assumptions to make, as well as what those assumptions will impact in terms of your final sizing and design. And then we're going to have a conversation around pros and cons of different HVAC systems. This whole presentation isn't meant to be a Trane commercial. We're really trying to just give you a broad view of the different systems on the marketplace today and the various advantages and disadvantages of each. And then we're going to tie everything in together. And I mean that in a pun type of way, in terms of tie-in. We're going to talk about controls, which would be tying in all of your irrigation, lights, HVAC, and other systems as you so choose. With that, we'll get started with item number 1. So market naming. So when people refer to indoor agriculture, people can refer to it as a grow house, indoor gardening, industrial agriculture, urban agriculture. We see a lot of the same type of techniques being used with all of these different types of terms. So if you hear these same type of things, just think that you're growing some sort of a crop inside and making an artificial environment to do so more effectively. What is it? Is basically a technological approach to growing which allows the grower like Michael Ward, who's CEO of Harbor Farms, to set the ideal growing environment for each crop in terms of type, but also in terms of age of crop. Some of the key benefits that we're seeing in the market space more generally, not just cannabis specific, is a lot of the irrigation rates, although they are high, you can reclaim almost all of that water back through the HVAC system to condensate reclamation systems and put it back into the plants. So the overall water that you're using compared to traditional farming is about 90 to 99% less. So that's a huge benefit as we kind of look forward to, I guess, some more challenges in the world in the next 50, 100 years and with respect to water availability, something definitely to keep in mind. The other huge benefit of indoor agriculture is that your crop yield per square foot jumps up about 100 to 350 times that of your standard, call it a cornfield. But generally just outdoor farming, you're going to have a lot more crop density here. So again, more taking advantage of better usage of space and allowing the growth of more crops and more of an urban environment to reduce transportation costs long term. So we see in terms of what's growing inside right now profitably, really everything. So you're seeing everything from cannabis, which is naturally a very profitable crop, but also all the way things down to like lettuce, leafy greens. I don't know those who have seen like Gotham greens in grocery stores around town, but that's all indoor agriculture produce that you find in anywhere from Whole Foods, Fresh Time, places like that. So really an approach to growing that we were seeing expanding by the day. Kind of jumping into the cannabis legalization market more specifically, as you can see here, cannabis is really taking the country by storm. We're seeing states turn over in terms of both medical and recreational use by the year, and we expect to see a lot more of these states probably move towards recreational or at least medical cannabis this fall during the election via different voting mechanisms. With that expansion, we're seeing a huge growth in terms of market size. Here's a chart here that kind of compares what we see in terms of the total indoor agriculture space. So that being both leafy greens like veggies, tomatoes, cabbage, whatever it is, compared with medical cannabis and recreational cannabis. Now, clearly from this chart, you can see that the bulk of the indoor grow space is still the cannabis market. The leafy greens is really a very small player as of right now in the market. But we are seeing this market as a total grow about 26% year over year, and that's happened for the last few years in a row. Now, Michael, I'd kind of like to kick it over to you quick while we're on this slide and just talk about what trends you're seeing in terms of what your investment strategy was and what you talked about to your investors in order to acquire capital for your build.
Well, when I got started in this 3.5 years ago, when the emergency rules were put in place in November of 2016 in Michigan, the only conversation we had was about medical. Recreational wasn't even on the table yet. But during this COVID period, starting in February to now June, the municipality that I'm in Kalamazoo, held all their city council meetings via Zoom, and brought the adult use to market, allowable, passed the ordinance and zoned everything available to us, and which really changed the marketplace considerably, especially since about 86% of all municipalities opted out of adult use. It really was a benefit to us to be in a municipality that was surging forward into the adult use market, and having multiple conversations about that with the city and understanding their plan. It was a big, that was a big feather in our hat to pick the right municipality that had the right ordinance, the right zoning, and the wherewithal to push ahead with adult use. So my conversation with investors was very limited on adult use because it was an unknown, but it really was focused on medical it back from the beginning. But now that landscape has significantly changed, and adult use, I would see that percentage greatly change in the next, year or two.
Thank you for that insight, Michael. Very, very good stuff there. So now that we've kind of talked more generally about the cannabis market, we're going to dive inside of the grow room as promised. So back to high school biology, hopefully. So we have two main parts of a plant, one being the shoot and one being the root. So the root is focused on bringing minerals as well as water from the soil into the plant body itself. And the leaves are there to, one, transpire that water back into the atmosphere as it brings minerals up through the plant, so it can allow for more flow through the plant body, but also to collect sunlight as well as CO2 for growth of the plant. So with that, we have a term that's very commonly used in this industry that is kind of a need to know, called evapotranspiration. And what it really is, it's two components. It's evaporation as well as transpiration. So the evaporation component is going to be water movement from the soil as well as the plant surfaces to the surrounding air. The transpiration component would be the water movement within the plants for eventual release from the leaf stomata. So as you combine evaporation and the transpiration rates from a given set of crops, you get the evapotranspiration, which would be the, basis for what your latent load in the space becomes. Now, a very key thing to understand with this rate is that transpiration rates, when the sun goes down, or in this case, when our lights turn off or dim, or whatever the control sequence states that they should be, whatever our simulated nighttime is, the transpiration doesn't stop. So that's what makes it kind of a difficult environment to condition properly, because if you were to have only a latent load when there's lights on, that would mean that there is always a sensible load to accompany a latent load. If that was the case, you would be allowed to use pretty much standard air conditioners throughout the gambit of what we're trying to do. The issue is that, unlike a standard building, when we go into unoccupied, we maintain our latent load through that period. The leaves will continue to transpire that water, and we will continue to have a latent load at night, which is really the key behind why dehumidification is so important in these spaces. You can't just have cooling, you need to have both, and they need to be independent of each other. Michael, this is a really important thing for your grow specifically. I know one of your internal grow experts has put a huge onus on the dehumidification during the nighttime mode, and especially during the transfer period between day and night. Just kind of wanted to ask you to touch on that and why it was so important.
Well, as you put in the slide, the transpiration rates decrease by 2/3 when the lights are off, but better understanding how to bring those lights down. It's not like you walk up and you flip a switch and you walk out of the room and the lights go off. You definitely want to try to mitigate that type of shock to your plants, because although if you were to, let's say, sing a lullaby to your plants, the length of that time in the song while you're bringing down the lights is much more natural as the sun is setting versus somebody coming in and just flipping a switch. The plants themselves don't exactly know what to do when they have such a vast, definable moment of the lights are on. Oh my God, imagine your alarm clock going up and the shock that gives you. If it was a melody that kind of woke yourself up and you got to the chorus and now you're up, that's a different story. It's definitely mitigating the transpiration, better understanding the transpiration by bringing your lights up and down slowly instead of shocking them with 650 ppfds, or 1,000 ppfds, depending on what light spectrum you're working on at the time.
Absolutely, Michael. Absolutely agree. And, a really critical thing to understand for all growers getting into this space. So now moving into another topic that's really critically important, understanding how both plants and, I guess cannabis more specifically interact with the temperature and humidity in the space. And it's called vapor pressure deficit, and also known as acronym VPD throughout the industry. So we're going to start out with just the scientific definition. And I'm going to read it out. I don't like reading off my slides verbatim, but in this case I will. So the vapor pressure deficit is the difference in vapor pressure between the saturation vapor pressure and the vapor pressure in the room at the dry bulb temperature of the leaf. So on a psychrometric chart, here's what it looks like. So hopefully you can see my mouse, but basically the top green dot is what the vapor pressure would be at the saturation curve. So that would be at the point where the air in the room could not hold any more water within its certain volume. What we see on the lower green dot is what the room vapor pressure actually is. So that's measured in terms of the relative humidity. Typically a sensor on the wall would measure the relative humidity in the space, and then you would plot that along with the dry bulb temperature. So that would be the temperature that a thermometer would read in order to obtain what the room vapor pressure is. The difference between that and the saturation vapor pressure is your VPD, or vapor pressure deficit. Hopefully that makes some sense. Hopefully this chart is helpful. Again, I think these slides will be released regardless to the group for further investigation. You'll be able to contact us afterwards if you want to dive deeper into it. But basically how it impacts the plants themselves, if we have a low vapor pressure deficit. So again, going back to the side, a low VPD would mean the delta between your point in the room and the saturation point is small. So that means our humidity is actually high, kind of counterintuitive. So when we have a low vapor pressure deficit, that means we have high relative humidity. The transpiration rates are actually going to be lower. It's going to be more difficult for a plant to transpire water to the air around it because the air around it is already so saturated. This will actually lead to excessive pressure within the plant, which means, you'll actually get this sort of an effect on a leaf where water gets kind of forced out through the edges. Again, the reason why the plants need the water is because it's its only transportation mechanisms in order to get minerals to the cells throughout the plant. So if we don't allow for proper movement of water out of the plant, that means that our room is too humid. We won't get the proper minerals to the plant itself, and we'll also keep the plant overly saturated throughout its life, could increase the likelihood of rot, fungus, mold growth, which, in Michael's concern, which would be a plant or crop that you can't sell as flour. On the other end, if we had a high vapor pressure deficit, again, a large difference between the saturation point and the point of vapor pressure in the room, that means we have a low relative humidity. That means our transpiration rates are going to increase too much. Again, the air is acting as a dry sponge. It's going to suck any bit of water it can out of the plant, which means that there's going to be too much water flowing through the plant from the soil, which is actually, the plant is going to react and it's going to try to curl inwards in order to decrease that plant surface area. Either way, your plant is going to be very happy with too high or too low of VPD, because you're artificially and negatively impacting the rate in which water and minerals flow throughout the plant's body. So there's a chart a lot of us are familiar with, is a VPD chart. So you have on the x-axis relative humidity expressed from 0% to 100%. And then here you have ambient air temperature expressed from 50% on the top of the chart and 106 degrees on the bottom of the chart. Now, granted, this is more for an illustration purpose only. We would really defer to the growers themselves in terms of the optimum temperature and humidity and VPD, which is a combination of the two, that they would like to grow their plants at. But generally what we've heard is that this green area is where plants would like to perform. So what's interesting about this chart is, so you have a VPD, let's say, of 1.3. Again, this is the vapor pressure deficit in kilopascals between the point in the room and the saturation curve. So at this point, you can get 1.3 at 76 degrees and 56% RH, but you could also get 1.3 at any single one of these values and combinations throughout this chart. Every single one of these is going to have the exact same deficit from the saturation curve as your 75, 60, 56% RH point. So why does this matter? Now, leaf temperature is critically important in the grow facility. So you typically want to choose a dry bulb temperature that, again, your grow team deems acceptable. But what's important to note is if you have flexibility with your grow temperature itself, and you'd say, let's say you want it between, just for example, say 70 and 80 degrees, but you want to make sure your VPD is X, you can choose a point at which to design your system at a more favorable load standpoint. So something that's easier to achieve with less air conditioning and yield the same VPD as you would otherwise. So just something to keep in mind a lot of times if you want a specific dry bulb temperature and specific VPD, you're going to need to spend a lot more money on your systems to achieve the same goal that you could achieve at a different point and have the same impact on the plants. So we are going to jump in right now to the types of grow rooms that we see in our facilities. So typically we see propagation or clone rooms, vegetative rooms, mother rooms, flowering / bloom rooms, and drying / curing rooms. Now each of these rooms is going to have a very different set of parameters that it operates under and different needs in terms of cooling, heating, dehumidification, or humidification. So in our clone rooms, typically we have, again, our cuttings from the mother plants and are used to grow new plants. Very low transpiration rates. The reason why is because your plant surface area is relatively low in this stage of the growth cycle. You're basically a lot of times going to need to add humidity to the space or actually have covers over these plants in order to maintain all that humidity that those plants like to have at that age. Typically it's going to be warmer in that room and a little bit more humid, and your lights on period is going to be a lot longer than other parts in the growth cycle. Your vegetative room, again, growing the plant, our transpiration rates are going to increase as the plants age and gain more surface area of leaf. Typically, we're going to have a little bit less humidity in this space and a little bit less light in terms of hours per day. The mother room, again, these are the mature plants that we're getting cuttings from for our clone rooms. They, again, are going to have very high transpiration rates. Again, the transpiration rate is going to be directly related to the amount of leaf surface area in the room. So if we have large plants with lots of leaves, that's a lot of transpiration taking place, which means you need to have a lot of dehumidification capacity in that particular room. Again, lights on, similar to the vegetative room in terms of around the 18-hour per day mark. Again, these values are things that we've heard amongst the industry and different jobs that we've done. The exact recipe for growing is really up to the exact grow team that you have put in place and the exact strains that you're trying to produce. The flowering and bloom rooms, again, they are not going to grow flowers until your light exposure is decreased, simulating the end of summer. So again, you're not going to have just them baking in the sun the entire time. So you're going to just kind of simulate that flowering period in order to allow the plants to produce buds. Now, a drying and curing room, again, the plants are no longer part of their, root system, call it. So your lights are really not going to be that important in this room. Again, they're going to be mainly an occupancy sensor, so a worker can go in there and investigate what's going on and how the plants are doing in their drying and curing process. So other than lights, temperature, and humidity, some other considerations that are going to be different for each one of the grow rooms is going to be the CO2 level. A lot of times you're going to put CO2 into these spaces artificially in order to stimulate the plants to grow at a faster rate. Also, the room design itself can be different depending on exactly what room type it is. Is a room within a room? Is it a less critical space? Exactly how that room is designed, the insulation around it could vary depending on the room type. Additionally, the methods of irrigation could change. There's a lot of different irrigation methods out there. We're not going to dive into all of them today, but based on the plant's age and, I guess, the critical nature of that plant, you're going to irrigate them differently. And then also the type of lighting, whether you're going to go high pressure sodium, something that gives off a ton of heat, but is a little less expensive, or you're going to go LEDs. Again, depends on the amount of investment you're going to make in a particular room and your, long-term financial goals of the facility. With that, I'm going to kind of pass it back to Michael quick here. We talked about a couple things in here. What other kind of, parameters did you guys look into, and how did you determine your parameters for your facility?
Well, when we designed Harbor Farms, it was crucial to me and our team that we were efficient on every aspect of the build. So all of our HVAC, all of our humidification, all of our dehumidification, and our choice of lights is a factor that you have to calculate what it is that you want to achieve. To be honest with you, HPS was not even something I considered after we did do a large amount of testing with many different HPS lights, but based on the energy efficiency of this building and how we spec'd out with you, Mitchell, what we were going to put in the building in relation to our HVAC, we chose LED lighting. The use of HPS and the amount of heat that's created in the space was counterintuitive to our thought process, and we did a long test with many LED providers and chose Fluence lighting, which is one of the most efficient LED lights on the market today. And we have been able to achieve really total control of the rooms without just pumping heat into the rooms. And our cooling factor is at such a low level comparatively. The heat that's put off by HPS, it takes the humidity out. So now we're talking dehumidification in this. So then you need to think about how you're going to add humidification. So that's a whole nother discussion of how, your HVAC will not give you enough humidity on top of the dehumidification to keep those levels at the right level of humidification. So it's a double-edged sword. There's so many factors that go into that particular thought process. I mean, don't get me wrong, HPS does fabulous things, and they grow some premium product, but it was not us being completely organic and looking to be as efficient and energy efficient as possible, and try not to stress out the grid as much as others, especially with the fact that we've got a very small footprint, but we're large in scale.
Absolutely agree. So with that, we're going to go into the load design itself, and we're not going to go through the exact, load programs and do a simulation here, an energy run, but we're going to go into, first off, just why this isn't normal air conditioning, why we can't apply the simple, 1 CFM per square foot and 400 CFM a ton and throw a package rooftop on our roof and call it good. If you do that, I will give you my personal guarantee that it will not function the way you intended to if you plan on growing plants in that environment. So a couple of reasons why that won't work. In our comfort cooling applications, we are going to traditionally have an occupied mode or an unoccupied mode. We'll use a school for an example for our left column here. So again, are the kids in the classroom or are the kids not in the classroom? It's very simple. Your ventilation rates are going to go off based on the occupancy in the room, and they're going to come on based on, again, the amount of kids in that room, and they're going to vary the OA to there based on CO2 sensors and actually use OA to flush out the carbon dioxide in that room based on the amount of kids in there. Your space temperature is usually around 70 to 75 degrees in most cases, and your humidity wants to typically be around 50 to 60%. Your sensible heat ratio, so that would be your sensible load in the space divided by the total load in the space, is around 0.7 to 0.9. So that means that 70 to 90% of the load in that space is sensible load. So again, that is a temperature-based load, not a humidity-based load. In indoor agriculture, everything shifts. You don't have an occupied and an unoccupied system. You have a lights on daytime mode or a lights off nighttime mode. There's always going to be plants in that space. Well, I guess typically during your process time, there's always plants in that space. You can always set a room into unoccupied if you don't have any plant matter in the room. But if there's plant matter in the room, it's either daytime or nighttime. Your lighting intensity goes way up from the normal 1 watt per square foot we see in a comfort cooling, just normal building, all the way from 30 to 80 watts a square foot, again, depending on the type of lighting that you use in that room. Your space temperature can vary widely. It can be all the way from, cool and dry in a curing room, all the way to really warm and humid in a clone room. It really depends on exactly what type of room it is, as well as the stage of the plant's life. So you have to have gear that will be flexible enough in order to maintain every possible condition that you might see in your facility. Your sensible heat ratio goes all the way down from, again, 70 to 90% sensible, all the way down to about 25 to 50% sensible during the daytime. So again, half to 75% of your load you can expect to be latent in nature. So that is a humidity-based load. At nighttime, it goes all the way from 0, absolutely no sensible load is possible, up to about 0.4. Again, it depends on your building construction, skin loads, those sorts of things. Ventilation, often you have no ventilation at all in these rooms. The introduction of OA into a facility where you have critical plants being grown, or plants that are very high dollars, per pound that you yield, you don't want to risk bringing in molds, mildew, pests, anything like that from the outdoor environment into your facility. So any OA that you do bring in, you're probably going to want to have HEPA filters after the DOAS units before you bring them in your filter. Again, assure the quality of that air coming into your building. but also you probably want to isolate your rooms as much as possible. That's a technique that we've used in the past and had a lot of great effects by purifying and keeping the air within those rooms themselves. Carbon dioxide, again, in our indoor agriculture space, we're going to increase way beyond ambient to stimulate as much plant growth in as short of a time as possible. So our process manufacturing, again, our lights on daytime, just for an example for everyone to kind of see how this works. When our lights are on, we have a high sensible load, so a temperature-based load from the lighting. And we're also going to have a high latent load from the evapotranspiration of the plants. Again, the lights are on, the plants are breathing. They want to bring up the minerals through the plant body. So we're going to have both of these loads in here. You're going to have sensible cooling and dehumidification loaded in the space. When our lights go off, cute slide, thank you, I know. We're going to have no sensible loading from the lighting at all, and a smaller but still significantly sized latent load from the plants. They're going to continue to transpire like our chart showed in the beginning of the slides. So we're still going to have a large dehumidification load or a latent load in this space, even when the lights are off. So the things you really need to consider when you're doing your load design, there's a lot of programs out there. Trane has a program called Trace, Carrier has a program called HAP. There's a lot of different load programs out there. A lot of people use spreadsheets. It really depends on the amount of risk and development you want to put into your process in terms of calculations. But the things you need to make sure you're accounting for are your lighting loads. So a lot of times that's just given from your lighting vendor. Your envelope loads get a little bit more complicated. You need to have probably a professional engineer stamp a set of drawings that talk about your envelope loads. Your people loads, again, that would be more of talking about your office spaces and things like that in your facility. You're also going to have a lot of internal loads. A big one is going to be your dehumidifiers. If you use series dehumidifiers in your space, like from Quest or Andon or whatever, you're going to have a large sensible heating load generated from those devices. They're transferring latent energy into sensible energy, and you need to understand that you need to take that out of the space. It doesn't just happen for free. Another thing would be fans in those spaces. Again, those fan motors are going to generate heat. Any kind of pumps in there for irrigation are going to generate heat. That's the natural inefficiency of AC motors in our modern buildings. Infiltration can be a factor. Again, if you pay a premium for your facility, often your infiltration, that meaning air that comes into your room from the outside, that can be brought down to nearly zero. But again, if you're trying to retrofit an old warehouse, your infiltration rates may be relatively high. Ventilation ideally is zero in these types of spaces, at least for the process zones. And then your sensible cooling effect from the evapotranspiration is kind of interesting. In the same way that the human body has evaporation going on in the skin during exercise or whatever, when sweat is produced, the plant has the same sort of an effect. So when you have moisture evaporating off the plant leaves, you're actually going to have a cooling effect that takes place in that zone. So you can take credit for that in your load calculation. So you don't have to assume that you have to take care of the entirety of the lights unless your plant surface area is such that you won't be able to take a credit for that. Latent loads are going to all come from plants, people, infiltration, and ventilation. So again, where is our humidity coming from that we need to take care of in our space? The critical points for sizing these HVAC systems, you got to, one, take into account your largest sensible load. So that's when every single light is on in the room and your lowest transpiration rates. Again, our transpiration rates are going to give us a cooling effect that we can take credit for. So if we have a room with low transpiration, we need to understand that the largest sensible load is what we need to handle entirely with the HVAC system. The largest latent load, again, is going to be when the lights are on. Think about this. It's when lights are on and when the plants are the most active. So you're going to have the most latent energy coming from those plants. Even though the latent energy is still significant during nighttime, it is always peaked during the daytime. The maximum reheat required. So again, this is more of a concept around dehumidification. In order to remove humidity from an airstream, there's two ways to do it. One of them is by using a desiccant to move the moisture to a different airstream. It's often very expensive and a very high temperature process. The other way is to cool the air down to below its saturation point to remove the humidity from that block of air. That's what's traditionally done in any kind of series dehumidifier that you see. You cool down the air to, call it 55, 50, 45, whatever that temperature is, in order to wick as much humidity out, and then you reheat it, typically with its own energy, whether that's from the compressor or the condenser. You usually have it downstream of that process. It reheats so that you don't overcool the room when you're trying to dehumidify. Potential grow room risk if you mess this up and you don't do the calculations correctly. You can have a lot of thermal stress on your plants. You can have white mold and mildew, insects, pest, cross-contamination, or complete loss of a crop. This is where another one I'm going to want to tag Michael in on in terms of risk management in a facility with regards to HVAC.
Well, the risk, there's a whole lot of factors that go into mitigating your risk. You need to decide on what your plant count is in that room. You need to decide on what your lighting structure is in that room. You need to know if you are going to do a retrofit, what your intended HVAC controls and dead bands are in that room. And all of that, the transpiration and all that calculations that happen is really based on the plant count and light usage. So if you go HPS and you go 1,000 plants per room, that's going to factor out to something very different than running a smaller, you know, let's say 500 plants in an LED room. There, in these particular situations, you know, the mini split is not even something that I've even considered at this point. We went so far beyond the fact that we calculated our plant counts and really worked with Trane on understanding how tight we can make these parameters. Let's just say I've got my clone room up on my screen right now. I've got a 2% dead band on humidity in that room, being controlled by my humidifiers and my dehumidification, depending on the calculation of what's going on in that room and how many plants are in that room. That's really the biggest part that I would have to say is once you decide on those rooms, how and the methodology used, whether it's a rolling table, whether it's vertical racking, whether it's hydroponics, whatever it may be that you want to do, those factors need to be relayed to a team like Mitch and Trane, because those factors you could build the perfect room and it will not work out the way you think it's going to work out.
Yep, very good point. Proper planning on the front end is absolutely critical to have a good result on the back end. It's absolutely critical. So with that, we're going to dive into, I think, what a lot of people came here to talk about. I like to talk about the science first and the product last. So we'll talk a little bit of product here at the end, not specific to Trane, but again, all the systems we're going to talk about today are things that you can buy from pretty much any vendor out there. Now, granted, if you ask me who makes the best stuff on the planet, I think you know the answer that I'm going to say. But all of these different types you're going to be able to find generally on the marketplace. So there's three basic types of systems that we see in this space. One is going to be combining traditional DX package units or split systems with in-space dehumidification, also known as series dehumidifiers. So this would be your Quest units. There are purpose-built DX units. So that these are units that handle both the latent load as well as the sensible load in one unit. And then there's more applied systems. So that's taking advantage of chilled water and hot water systems with air handling units throughout the space to again handle the entirety of the latent and sensible loading with one unit. So these systems differ in terms of both cost, complexity, implementation time, as well as the technological aptitude of your maintenance staff on site. So let's start out with the first type that we like to see. This is probably the most popular type. Now, within this type itself, there's a lot of subsets to it. You can vary the complexity of the individual components wildly. And so basically you have a DX package unit or a split system of some kind handling the sensible load. So again, that's the temperature control of that space. And then you have a series dehumidifier handling the entirety of the latent load in that space. So your advantages, it's going to be relatively simple to install. Again, nothing is simple in this business, but it's going to be simpler than designing hydronic systems that go throughout the building. The service generally becomes quite simple. The machines tend to run very well on themselves. Just filter changes and basic maintenance is required. The technology is very flexible in terms of load management. So with certain types of facilities out there, and I won't give away all of Michael's trade secrets here, but you have varying levels of both efficiency, capacity reduction, and tolerances available in this space. And the other important thing to note with this type of equipment is that it's readily available. Pretty much all of these types of units are either stocked or very short lead time. So a lot of the businesses that get a permit want to get up and running as soon as possible. A lot of that is actually mandated by the state, depending on what state you're trying to operate in. So readily available is often a very important and integral part of these builds. The last thing is that it's very easy to establish N+1 redundancy. When you have a lot of units like this throughout your space, you can just put an extra one in your space and boom, your redundancy is complete. There's no other thought you need to put into that redundancy. Your drawbacks, without proper building automation, you can have units that fight each other. That means that one isn't heating and one isn't cooling. Again, with proper automation, you don't have that problem. But if you try to do it on the cheap with 2 thermostats in a room, often the signal coming from each stat may be different. Again, if you don't have variable refrigerant flow equipment or variable speed compressors, you can have rooftop or split system cycling, which can lead to premature failures. Your unit quantities are going to be relatively high for this type of a system. But again, that unit quantity as a downside in terms of electrical connections is also a positive in terms of the redundancy and resiliency of the system. And then generally it's going to be energy intensive just based on the number of compressors you're going to need to operate this system. And there's limited opportunities for economizing or free cooling. The next type of systems that we see out there are purpose-built DX units. Now these come in either split or package systems. What you're going to see is that this unit is going to do all of the latent cooling as well as the sensible cooling for a certain zone. So that means that the operating modes are integrated and packaged within the unit itself. They're still going to be relatively simple to install and simple to control. Again, you give it a temperature set point, you give it a humidity set point, and you go. And you do have opportunities for improved energy efficiency, mainly through what we call water side economizing, which I'll talk about next. The drawbacks on this is that the equipment cost is going to be higher. The amount of roof and building penetrations that you're going to have is going to increase. So again, that could be a risk factor for your build. You're definitely going to need more skilled service personnel on site, and the lead time of the items is going to be significantly longer with this sort of equipment. In terms of the energy efficiency opportunities doing this, one of the things, if you have what's called a condenser water loop serving self-contained units in your building, so that means that you have a cooling water loop throughout your facility, and then you have individual units with compressors in them to basically reject heat from the room to that water loop, which then sends it outside. You have an opportunity that during the winter time, you can actually use that heat rejection device outside to produce very cold water based on the ambient condition, and use that water to cool your facility as opposed to using mechanical compression. So that's an opportunity for energy efficiency with this system, but also adds a degree of complexity to it that you wouldn't otherwise have. Another type of system out there, and this is on the more complex side, would be using chillers and air handlers. Advantages, chillers and air handlers are very, very flexible and robust, generally speaking. Whatever you throw into a chilled water coil, you're going to get your set point coming out the other side as long as there's enough capacity to fulfill it. There's a lot of opportunities for water side free cooling. Again, using our heat rejection devices outside to produce cooled water for us using ambient air instead of mechanical compression. You also have opportunities for heat recovery in these systems. So again, taking condenser heat that would otherwise go to waste in the ambient temperature and using it to use, whether that be through reheat coils or through domestic water heating in the system. The operating costs, again, if you took advantage of all those opportunities along the way, you could get the operating costs down, especially during the wintertime months where you wouldn't be paying for compression. And then your efficiency, again, opportunity is high, but that's only if you do it in certain ways. The drawbacks, it's definitely going to be the most expensive way to build your facility. Your service personnel on site are going to have to know what they're doing. They're going to have experience with chillers, experience with air handlers, experience with BAS in order to really, call it tame the system into working properly. You can't have someone who's just used to doing filter changes and call it a day on your site. You really need someone that knows what they're doing. The lead time is definitely going to be the longest with these items. You're talking months, not weeks. And that redundancy becomes a lot more complex. You need to build in redundancy in both the chiller systems, the pumping systems, the air handling systems, and the redundancy gets a lot more difficult as we start to scale up in this way. Now with that, I want to talk a little bit about controls here at the end. And it's about managing the grow room environment in a way that makes life easier on the owner and operator of the facility. So again, what are the things we're trying to control in our spaces? We're trying to control temp, humidity, which by yielding temperature and humidity, you get to your vapor pressure deficit value. So again, those two things are, if you know a temperature and a VPD, you get humidity. A humidity and a VPD will actually give you a various set of temperatures, but you understand what I'm trying to say there. So basically you're controlling two parameters to yield a parameter that the plant knows and interacts with. You're also controlling your lighting in this system. So again, your lighting, your temperature, humidity, and your CO2 levels are all going to interact to create a grow environment that you want. Your tolerances should be able to be set through this system as well. Things that are optional, you could add irrigation and fertilization to these systems, but a lot of times it gets very complicated very quickly. A lot of the devices that are specialized in irrigation aren't BACnet native, so it can be difficult to integrate those systems into a formal building automation server. Integrating with the workforce, is another great reason to pursue building automation in your facility. So you can stagger your rooms. You can have different rooms in daylighting at different times of the day in order to flatten out the amount of energy that you're spending. Again, using a more consistent energy profile throughout the day can lower your utility costs depending on your demand rates. Rachel can talk a lot more about that than I can in terms of her specific demand rate structure. And then also bringing all of this to an automated version of control in order to decrease your headcounts on site. Using wireless sensors at your facility. Again, our brand of wireless is called AirFi. But again, a lot of different people have wireless sensors in this space. Again, using wireless sensors in these grow rooms can allow you to move and place these sensors throughout your grow racks and prevent any kind of microclimates from developing in your systems. With that, Michael, I wanted to kind of talk open up the floor for you to kind of talk about integration of different systems in your facility and kind of your experience with that and the importance of integration throughout the build.
Thanks, Mitch. What we did with Trane is work through their ensemble program, which is the illustrated slide a couple slides ago. For instance, that's their dashboard for their particular that they showed us when we were signing on. This is the first time they had ever done something like that in the cannabis space. I believe that this particular dashboard was used for schools and whatnot previously, but we've dialed it in to use it for cultivation purposes. For instance, I have ensemble up right now. I've got bedroom 1. I can tell you that my tier delta temperature differential is 1.7 degrees. So what that means is if you go back to that slide with the temperature reading, I have all of those are mobile throughout the rack, and we keep it at the canopy height. So I know that tier 1 temperature is 78.2 degrees, tier 2 temperature is 78.3, tier 3 is 79, and tier 4 is 79.7. So to give you some sort of reference, tier 1 is 5 feet off the ground and tier 4 is 25 feet off the ground. So I have a temperature differential from 5 feet off 1 foot off the ground to 25 feet in the air of 1.5 degrees. That's only achieved by us understanding what is actually going on in that room and how, and again, based on what we're doing in the room, we're in veg. So we're in our 3rd week of veg in that room. So it's understanding what we're doing and really keeping an eye. If you're interested in vertical farming, you have the understanding of microclimates is the biggest problem that you can run into. And if you don't mitigate that by understanding and using these type of sensors, could become a major problem. You're going to have definitely a different plant from tier 4 to tier 1, depending on the strain. So by doing so, we signed on with Trane to use their control system. And what that enabled us to do is I have, between my head cultivator, myself, and my production manager, we have 3 locations that we can change any set point and any room at any time without even entering it. We also have displays outside of every room that we can control everything throughout the room, from the lighting, the humidification, dehumidification, temperature, heat, CO2, all from a stationary display outside the room, thus mitigating, my IPM manager would love this, mitigating the fact that you need to enter that room at all to adjust the temperature. Every time you walk in those rooms, it could be a biosecurity situation. We do everything remotely. They have minimal interaction with humans, and we are the biggest carrier of problems that walk in those rooms. So not having shared air and mitigating how many people and how many times you need to enter that room is a big part of it. So being able to control everything from outside the environment and getting all the data you need online or in your office, or we have touch screens set up in our production office and our main offices that we can sit there with the team and adjust things on the fly if we need to, without ever even going in the rooms.
Absolutely. That's the big benefit of doing things right. With that, I'm going to pass it off to Rachel. I know that we're short on time here. I'd love to dive deeper into that, but I have to be respectful of Rachel's time as well. So I guess I'll let them take
I'm
from
going
here.
to interject here. Hey, Al, it's the moderator, Jillian. Mitchell, Michael, thank you so much. That was an amazing amount of information. And for everybody who's on the call who wants to learn more about what Mitchell and Michael had said, the recording is going to be on our cannabis playlist. And on the, sorry, Rachel, you caught me off guard. The cannabis playlist on our YouTube page, and also the recording will be sent to you in an email. I'm going to pause right now for to send a few questions over Mitch's way before we begin on Rachel's. And for everybody who is able to be on the call, we got 10 more minutes on the call. And then we're probably going to go over a little bit just to make sure that we get everybody's questions answered. So if you are able to stick around, please do. So we got some questions, Mitch, for you from Mike. He asked earlier, I'm going to go find that question from Mike. How do you control the BVOC or the pot smell on exhaust air if you bring in OA?
Yep. Great question. Great question. So we specifically address that by using carbon filtration systems. So Michael's system specifically, and the ones that we recommend more generally throughout our spaces, use carbon trays that you actually recharge. It's a lot of lower cost and more effective way of reducing the VOCs coming out of your facility than just using carbon filter or carbon impregnated filters throughout your facility. So using carbon trays are lower pressure drop, better for the environment, easier to recharge, and something that we definitely recommend in all these facilities. So that's all on the exhaust side of those DOAS systems. So before it goes through your energy recovery devices, it goes through that carbon neutralization array.
Perfect. Mike, if you want to follow up with that, please do. And there's another question that can't come through specifically regarding your presentation, Mitch. It was asked, is there an electrical kW calc per square foot for different systems?
Well, I guess I'd recommend generally against using square footage calculations because they can generally give you maybe a good idea of the amount of cooling you need, but the amount of cooling you actually need will be directly related to the amount of plants in the room, the amount of lighting and type of lighting in the room, as well as your irrigation rates and assumptions in regards to runoff and other parameters. So we'd really recommend doing a full-blown energy calculation for each of those rooms to determine the exact loading in the space.
Great. And so again, folks, if you need to follow up on that, please do. So for folks who aren't aware, we have an early bird option where you send any questions ahead of time for our panelists to have an understanding of what your curiosities are and for us to be able to answer those during the presentation. Something that had come through from Brian is a question about your design overall and how you structure them. So he asked, have you designed for simultaneously occurring heating and cooling, humidifying, dehumidifying? Do you transfer that between rooms, or are they isolated entities?
So you can do it either way. There are ways to transfer those things. That in general, the dehumidification and the humidification in terms of water usage, typically all of the water that you remove from the air goes through a condensate reclamation system, and then that water is purified and then sent back into your system. In terms of sharing, I guess, heating loads and simultaneous heating and cooling and simultaneous humidification, dehumidification, that typically depends on the deadband that you set in your system. So again, that's something that's adjustable. The tighter the deadband you operate in, the more frequently you're going to cycle the systems in that space. So let's say your deadband is 0.1 degrees Fahrenheit, your cooling system is going to kick on to make it 75.1, and then your heating system is going to kick on when it's 74.9, and it's just kind of going to bounce back and forth. The more of a deadband you give it, the less the systems will fight each other. But again, the more deadband that you have in your system, although it's less fighting between the systems, it'll have a negative impact on the plants long term. So finding that perfect balance is both a decision in regards to plant quality as well as your utility costs.
It seems like a lot of things to consider. Would you, when someone's approaching this for the first time, what just general bullet point advice things would you give to them for them to make sure they're looking at while they're making these sort of systems?
I'd say that's a great question for Michael more than it is for me. He's the one with the best experience there.
First word is run. No, it's the one thing that really shocks me in this industry is, and Mitch can attest to this, we have no shared air through this building. You can walk through this building, there's not one bit of shared air that's from one room to the other. My expertise is the fact that if you share air in this particular, being a cultivator and sharing air through your facility could absolutely destroy everything. You know, if you could have powdery mildew, you could have some sort of outbreak, spider mites, you could have a humidity spike, and all of a sudden it's not just one room, it's every room. You know, and when you're working in this environment, which is a high energy use environment, you know, separating everything and being efficient and sizing things properly is the most important thing. And that is by far calculated on what you want to do in that room. It has everything to, our veg rooms are different than our flower rooms. Our flower rooms are different than, of course, our dry rooms. And every room is different. And that you have to consider that every bit of it has to be taken into account. And you really have to understand what you're going to do in that room, how many people are going to be in that room. That's another added heat load, you know, and there's a ton of different factors that go in. But if there was anything that I could tell anybody, do not share air. Do everything possible to not share air between your flower rooms and your bedrooms. Everything should be independent of itself. We do not have any shared air in our building. All of our air is scrubbed and clean. We joked about it recently when Trane brought their army in to show us what was going on, that the air is purer in this building than it is outside, that's for sure.
Right.
So it's, there's a lot of different factors that go into it. I don't, personally, HVAC is the most expensive thing that was for this project, by far. Mm-hmm. So that consideration was made, not for the fact that we just had the money to do it, which because we didn't, and we had to talk our way into doing it with, and by speaking with Mitch and the team, the efficiencies that were created during these discussions were so off the charts that the fact is that they were going to pay for them. Their ROI was so quick, it didn't make any sense to try to go on this cheap, you know? So it's really important that, you know, the days of doing this in your basement and what works in your basement is going to work on a larger scale. Mm-hmm. Those days are over. Mm-hmm. And biggest part of it is too, is retrofitting existing buildings. You really need to get a team like Mitch in there to understand what you're trying to achieve, how you're going to move air, how you're going to lay out the internal walls in that building, and really what you're trying to achieve is the biggest part. And you can back your way into understanding what it is you need and how far and how deep you need to go. So that would be my recommendation.
That honestly, that you could have a TED talk on yourself, Michael. That was awesome. So I liked how you said that the ROI pays off almost immediately when you go for the quality, or like the Cadillac, as we were joking earlier. So it's
I wish there was Cadillac based funding in the trade system.
I think it's a perfect segue to how Rachel's program is able to help these businesses be able to achieve these results, and with the cash constraints that they have, or wherever they lie in that regard. So Rachel, why don't you tell us about what your program provides for cannabis folks who are looking to have quality equipment?
Absolutely, thank you. So just a quick introduction again, my name is Rachel and I work for Consumers Energy in the Business Energy Efficiency Program. So we offer this incentive program. Oops, sorry.
Oh, you unshared.
Yes, I did. Sorry about that.
No worries. So for the folks on the call, oh, here we are. So Rachel, you were saying?
So.
No worries, it happens all the time.
Right, yeah, my keyboard knocked over and it exited out of it for me. But all right, anyways, now we're back. So we offer this incentive program for different businesses throughout Michigan, including grow facilities. And our incentive program offers more than 425 different energy efficiency measures, 45 of those specific to agriculture. So you can receive incentives for things like your LED grow lights, your HVAC system, some dehumidification. We offer a very wide variety of things. And if for some reason there's something that you're doing that we don't offer an incentive for, there is a possibility to receive a custom incentive for it. Now, we do have a couple of rules with our custom incentives. One, you actually have to be able to provide saving numbers. You can't just say that this saves you energy and ask for money. We need physical data and proof to back up that data. And then the most important part is it must meet a 1 to 8 year payback period in order to be able to receive the incentive. So I just wanted to go over a couple of the incentives that we are currently offering this year. So we offer a fairly wide variety of HVAC incentives within our prescriptive program. So we have, on this page, you can see our split units and our RTUs. You'll see that based on the size of the unit, it has a certain efficiency it has to meet. And then it will give you a certain set dollar amount per ton based on that unit. It's pretty easy to fill out. You just click the drop down, plug in the information, and all of the application will fill out itself. We also offer incentives for heat pumps for some of you smaller guys out there. For our heat pumps, we do have kind of a high efficiency that they need to make. They need to meet a 21 SEER and have an HSPF of at least 10. Now, heat pumps, this is the only piece of equipment that will do it for. If they do not meet the efficiencies for our heat pump measure, but they do meet the efficiency for our split unit measure, we will allow you to take it under the split unit measure instead. So just keep that in mind as you're looking at your equipment. And then we also offer an incentive for chillers. Now this part can look a little intense, but don't be threatened by having to fill it out or anything. Honestly, if you can just give me the spec sheets and your testing information, I can fill all of this out for you. So don't let that be an intimidation factor or anything. Essentially, as you see, it's based off of the type of equipment and then the size of the equipment for the needed efficiency values that you have. And then we also offer a wide variety for heating equipment. So we have your different type of boilers, we have high efficiency unit heaters, we have furnaces. We really try and cover a very wide variety for you guys. And then this brings us to our custom incentives. Now, like I said, for the custom incentives, we will need to have an actual energy savings amount to calculate the incentive. And it also needs to meet that 1 to 8 year payback. Now this year, what we're offering custom incentives on is the standalone dehumidification units. Next year, that's actually going to be one of our prescriptive measures. We are trying to figure out ways how to incentivize the higher dehumidification units. Like, I know that there's like the decadent wheels and all of that other good stuff, like they are, you know, a much better system than just your standalone or portable dehumidifiers. We're just still in the works of trying to figure out how to actually physically incentivize those. It's all this such new technologies and such a new industry, especially to Michigan, that we're just still trying to figure it out, you know? So we're like everyone else. But another thing to keep in mind for the custom incentives is we have a 50% cap on the incentive. So if your project cost is, you know, 75% of the total incentive, it's going to be cut to 50%. Sorry if I'm saying that confusingly. So just for example, if you're having like $100 project cost and your incentive was also supposed to be like $70 or something like that, you would only receive a $50 incentive. That's pretty low for a custom, but just to make the math easy. So you might be asking, how do you actually qualify for these incentives? Well, first you have to be a Consumers Energy customer. If you are not a Consumers Energy customer, I strongly suggest that you reach out to whoever your utility provider is, because there's a very good chance that they also offer these incentives. And I want to encourage, you know, everyone to be efficient regardless on if you're a Consumers customer or not. So you have to be one of our customers. You have to have a federal tax ID number. So I'm sorry if there's any caregivers who are still working from their homes. As much as I would love to give you an incentive, unfortunately, this program is only for the commercial growers. And then if you have a new construction project, so you're erecting a brand new building, great, we can still help you as far as incentives go. You just need to be using our power at the end of the day. So how does the incentive process actually work? Well, first, we're going to check to make sure that you're a Consumers Energy customer. Assuming that you are, you're then going to submit your pre-notification. So your pre-notification is just going to let us know, you know, who you are and what you're doing. We review what it is to make sure that you qualify for, the equipment qualifies for the incentive. And assuming that the equipment does qualify for the incentive, we then will reserve those funds. So we set that money off to the side and it now has your name on them for when you're done. Next, you're going to install everything. Once everything is installed, you're then going to let us know and submit your final application. The final application is really easy. It's just a sign off saying, hey, my build is complete, along with the invoices showing that you bought the equipment that you said you were going to buy in the pre. Now, if your project is over $50,000, you will have to undergo a final inspection, so just be aware of that. And once we're complete with your final application and inspection and have all of the needed paperwork that we need, we then submit your application for payment, and then you will physically receive a check in the mail. It takes about 4 to 6 weeks for you to physically receive that check once it's been submitted for payment. So this website is where you're going to find our application and catalog, consumersenergy.com/start saving. We also have a really nifty find the contractor tool there. So if you know that you want to build, but you don't really know who to work with yet, feel free to use our find a contractor tool. You can look people up based on what kind of needs you need. So lighting, HVAC, building design, the works. And the bonus part is all of the contractors listed on our website are trade allies. And basically what a trade ally is it's a contractor who has come in to take a class with Consumers Energy to learn how the program works. And they essentially fill out the entire application for all of you, which is really nice because the least amount of paperwork you have to do, the better. But also don't let the paperwork intimidate you, because if it comes down to it, I'll fill it out for you. So, and so that just brings us to the end real quick. I just want to throw out, you know, like the incentives are very real. Michael's receiving over $100,000 for his HVAC equipment and over $200,000 for his LED grow lights. So it's very, you know, important to let us know what you're doing, because you'd be surprised at how quickly everything starts to add up once we get your project with it into our system.
Wowza. Wow. That is a great ending note, y'all. If you're curious about learning more, Rachel's contact information is right there. You know, thank you everybody on the call, and thank you to our panelists for staying on an extra 10 minutes and really, you know, diving deep into the intricacies of what we're talking about, from both like a balancing the budget point of view, Rachel, and from like balancing the science of it all. Mark left a really amazing comment earlier. I just want to read it out loud to make sure that everybody here is, if you haven't read it, panelists. He said, Mark says, thank you for presenting on a science and process-oriented systems in order to obtain asset management solution-based objectives. And so that's like one of the highest Yelp reviews I've ever seen. So thank you very much to all three of you for, okay, thank you, Drew. Thank you much for all three of you for being able to talk today. So folks on the call, if you have any last questions, now is the time. I see that there is questions open right now. I have a feeling that maybe I'm going to connect you with these questions later and we'll be able to answer for all the folks who had sent these in. So Mitch, not Mitchell, Rachel, can you please go to the next slide, please?
Maybe.
Yeah, take your time. And so for the folks on the call, and for panelists, if you want to come back and learn for yourself, we have one coming up about control specifically. I know there is quite a few questions about controls here in the questions for folks who are interested. And I know Mitchell, you and Michael have a deep experience in handling controls. So next week, Tuesday, same time, tweaking the margins, how to control, how controls set you up for a better yield and a leaner operational budget, operating budget. Thank you very much to our visionary supporters. And thank you everybody who stayed on the call. Rachel, Mitchell, Michael, thank you so much for volunteering your time to speak with us today. I'm really looking forward to seeing you guys in the future.
Thank you very much.
Absolutely. Thanks for having us, Jillian.
Yes, thank you. Everyone, have a great day.